Electric motors are everywhere. They are essential to our modern lives. We use them every day, but we rarely stop to think about them. These incredible machines power our world. From household appliances to electric vehicles, they are the driving force behind countless technologies. Imagine a world without electric motors. We wouldn't have refrigerators, washing machines, or computers. Factories would fall silent. Transportation would be a distant dream. Electric motors have revolutionized our lives. Their impact is undeniable. In this essay, we'll take a journey through the fascinating history of electric motors. We'll explore the key discoveries and the brilliant minds that made it all possible. The story of the electric motor begins with a surprising discovery. It was a time when the world was just beginning to understand the mysterious forces of nature that govern our universe. In 1820, Danish physicist Hans Christian Ørsted made a groundbreaking observation. Ørsted was a curious and meticulous scientist, always eager to explore the unknown. He noticed that a compass needle moved when an electric current flowed through a nearby wire. This was no ordinary observation. It was a moment that would change the course of scientific history. This simple observation had profound implications. It suggested that there was a hidden relationship between electricity and magnetism, two forces that were previously thought to be unrelated. It demonstrated a fundamental connection between electricity and magnetism. This revelation opened up new avenues of research and experimentation. Ørsted's discovery ignited a flurry of scientific inquiry. Scientists around the world were eager to explore this newfound connection and uncover its secrets. Across Europe, scientists began experimenting with electricity and magnetism. Laboratories buzzed with excitement as researchers conducted experiments to understand these forces better. One such scientist was French physicist André-Marie Ampère. Ampère was a brilliant thinker, known for his ability to translate complex phenomena into mathematical language. Ampère developed a mathematical theory to explain Ørsted's findings. His equations provided a framework for understanding the relationship between electric currents and magnetic fields. He showed that electric currents create magnetic fields. This was a pivotal moment in the history of science, as it provided a clear and quantifiable link between electricity and magnetism. This discovery laid the groundwork for the development of the electric motor. Inventors and engineers began to see the potential for harnessing these forces to create new technologies. The world was on the verge of a technological revolution. The discoveries of Ørsted and Ampère were just the beginning. Their work paved the way for countless innovations that would transform society and usher in a new era of progress and development. Today, we see the fruits of their labor in the countless devices and systems that rely on electric motors. From household appliances to industrial machinery, the principles discovered by these early pioneers continue to drive technological advancement. As we look to the future, the legacy of these early discoveries in electromagnetism reminds us of the power of curiosity and the endless possibilities that lie ahead. The journey of understanding and innovation continues, building on the foundations laid by the great minds of the past. The story of electromagnetism is a testament to human ingenuity and the relentless pursuit of knowledge. It inspires future generations to explore, discover, and push the boundaries of what is possible. And so, the journey that began with a simple compass needle continues to shape our world in ways that Ørsted and Ampère could have only imagined. The legacy of their discoveries lives on, lighting the way for future innovations. In 1834, a major breakthrough occurred. This year marked a significant turning point in the history of technology and engineering. Moritz von Jacobi, a German engineer, invented the first practical electric motor. Jacobi was a visionary, driven by a passion for innovation and a deep understanding of electromagnetism. Jacobi's motor was a rudimentary device. It was a simple yet groundbreaking invention that laid the foundation for future advancements in electrical engineering. It consisted of a rotating shaft with electromagnets. These electromagnets were strategically placed to interact with stationary magnets, creating a new form of mechanical movement. When an electric current flowed through the electromagnets, they interacted with stationary magnets. This interaction was a pivotal discovery, demonstrating the potential of electromagnetism in practical applications. This interaction created a rotational force. The rotational force was a key element in converting electrical energy into mechanical energy, a concept that would revolutionize industries. Jacobi's motor was not very powerful, but it proved that it was possible to convert electrical energy into mechanical energy. This proof of concept was crucial, as it opened the door to further experimentation and refinement. This invention marked the birth of the electric motor. It was a monumental achievement that signaled the beginning of a new era in technology and engineering. It paved the way for future innovations and sparked a wave of excitement among inventors and engineers. The potential applications of electric motors were vast, and the race to improve them began in earnest. The race was on to develop more powerful and efficient electric motors. Engineers and inventors around the world were inspired by Jacobi's work, leading to a flurry of activity and rapid advancements in the field. The impact of Jacobi's motor extended far beyond its initial invention. It laid the groundwork for the development of electric vehicles, trains, and a myriad of electric appliances that would transform daily life. Today, the legacy of Jacobi's motor is evident in the advanced electric motors that power everything from household appliances to industrial machinery and electric cars. The principles he discovered continue to drive innovation and efficiency in modern engineering. Jacobi's motor is celebrated in museums and educational exhibits around the world. It serves as a testament to human ingenuity and the relentless pursuit of knowledge and improvement. As we look to the future, the spirit of innovation that Jacobi embodied continues to inspire new generations of engineers and inventors. The quest to create more efficient, powerful, and sustainable electric motors is ongoing, driven by the same curiosity and determination that fueled Jacobi's groundbreaking work. From Jacobi's rudimentary motor to the sophisticated electric motors of today, the journey of innovation is a testament to the power of human creativity and perseverance. The dawn of the electric motor era, sparked by Jacobi's invention, continues to illuminate the path forward for technological advancement. The next major milestone in the evolution of the electric motor came in the 1860s. This was a time of rapid technological advancement and industrial growth, where inventors and engineers were pushing the boundaries of what was possible. The world was on the brink of a new era, and electricity was at the heart of this transformation. Belgian inventor Zenobe Gramme developed the first practical direct current generator, known as the Gramme dynamo. Gramme, a skilled engineer and visionary, understood the potential of electricity to revolutionize industries and everyday life. His invention was not just a technical achievement, but a leap forward in the practical application of electrical science. The Gramme dynamo was a game changer. Unlike previous attempts at generating electricity, which were often unreliable and inefficient, the Gramme dynamo provided a steady and continuous flow of direct current. This consistency was crucial for the development of electric motors and other electrical devices. It provided a reliable source of direct current, which was essential for powering electric motors. Before this, the use of electricity was limited by the inconsistency and high cost of available power sources. The Gramme dynamo changed all that, making electricity a viable option for a wide range of applications. Prior to Gramme's invention, batteries were the primary source of electricity. These early batteries were cumbersome, had limited capacity, and were prone to frequent failures. They were also expensive to produce and maintain, which restricted their use to only the most essential applications. But batteries were inefficient and expensive. They could not provide the sustained power needed for industrial machinery or widespread electrical distribution. This limitation was a significant barrier to the adoption of electric technology in many fields. The Gramme dynamo revolutionized the way electricity was generated and distributed. By converting mechanical energy into electrical energy efficiently, it opened up new possibilities for the use of electricity in both industrial and domestic settings. This innovation laid the groundwork for the modern electrical grid. It made it possible to power larger and more complex electric motors. These motors could now be used in a variety of applications, from manufacturing to transportation, significantly increasing productivity and efficiency. The impact of this development was felt across multiple industries. This invention paved the way for the widespread adoption of electric motors in industrial applications. Factories, which had previously relied on steam engines and other less efficient power sources, could now harness the power of electricity to drive their machinery. This shift not only improved operational efficiency, but also reduced costs and increased production capabilities. Factories could now rely on electric power to drive their machinery. This transition marked the beginning of a new industrial era, where electricity became the backbone of manufacturing and production. The Graham dynamo's influence extended far beyond its initial invention, shaping the future of technology and industry for generations to come.